A Tale of Two Sons. So basically, in this video, we are going to evaluate those two sums, and in the way diagram function is going to help us. Let us start with this one, since this one is easier. So we have the sum from n equals to 1 to infinity, 1 by n square minus x square. Okay, so this is just one of the application of diagonal functions. Basically, if you don't know what diagonal function, here's a general idea that I'm going to give you. Diagonal function of 1 plus x equals to diagonal function of x plus 1 by x, and diagonal function of x is just defined as derivative of gamma function by gamma function. And diagram function for finding diagram of 1, you can just find derivative of gamma of 1 by gamma of 1, and that's negative of Euler-Maclaurin constant. And because this is derivative of gamma of 1, and gamma of 1 is just 1, and yeah, and then you can just find all the values for diagonal function. But for us, the important property of diagonal function is diagonal function of 1 plus x is equals to negative of Euler-Maclaurin constant plus the Hn, and Hn can also be written as diagonal function of 1 plus x equals to negative of Euler-Maclaurin constant plus sum from n equals to 1 to infinity 1 by n minus 1 by n plus x. So this property is going to be helpful for us right now. This one. Yeah. And now if we have this, we can have other property too. 1 per diagram of 1 minus x, we will have negative Euler-Maclaurin constant plus sum from n equals to 1 to infinity 1 by n minus 1 by n minus x. Now if we have these two properties, we can subtract basically the second from first one, and we get diagram of 1 plus x minus diagram of 1 minus x equals to sum from n equals to 1 to infinity 1 by n minus x minus plus 1 by n plus this one will be plus, this is plus, this is will be minus. Okay, yeah. And now we can take LCM on diagram of 1 plus x minus diagram of 1 minus x is equals to summation from n equals to 1 to infinity here n square minus x square, and then we have n plus x minus n plus x. The n get cancels out, and we have diagram of 1 plus x minus diagram of 1 minus x. The x is constant for the sum, since sum involves n, divided by 2x equals to sum from n equals to 1 to infinity 1 by n square minus x square. Now for this we will need reflection property of a diagonal function, which is basically derived from the reflection property of gamma function. So the reflection property of diagonal function is diagram of 1 minus x minus diagram of x is pi times cot x pi. So you can basically derive this from gamma x, gamma 1 minus x equals to pi times sine n pi. Just differentiate both sides and you will get this expression. Okay. Sorry, this is pi times sine x pi. No, for this case, sine x pi. I'm sorry for that. And next, let's solve this. This one pi times cot x pi but wait, here we should have 1 minus x in x. We don't have that over here. So I was gonna make a mistake, but I just got it. Mm. And now we need to bring it to the form. So first of all, let us write this as gamma of x plus 1 will be 1 by x plus gamma of x, which I had shared earlier, and then minus gamma of 1 minus x by 2x equals to sum from n equals to 1 to infinity 1 by n square minus x square. And now we can take minus common, so that gives us 1 by x minus, and we get pi times cot pi x by 2x equals to this sum from n equals to 1 to infinity 1 by n square minus x square. And after that we can just distribute it to both the terms, and we get minus pi cot pi x by 2x plus 1 by 2x square equals to this sum. Now all the sum will be quite easier since we know this one. Okay, yeah, now this is one of the sum. So say if you have to find out sum from n equals to 1 to infinity 1 by let's say n square wait n square minus okay, so let's say we have to find n square minus 1 by 2 whole square. In that case it would be minus pi cot pi by 2 by 2 by 2 plus 1 by 2 times this will be 1 by 4. Now cot 90 is just 0, so this is 0, and this is 4 goes on the top, and we have 4 by 2, that's 2, so this will be just 2. Yeah. Now if we have now if in some cases if this comes to be indeterminate, for example if I had put 1, this would have been indeterminate, then you have to take limit and then do it. Okay, and so this one is done, and for the next one, so let me write it here. It's just pi cot pi x by 2x plus 1 by 2x square. For the next one it's similar, since we know that the next summation from n equals to 1 to infinity 1 by n square plus x square. So basically we can just put a negative sign over there and also introduce a I. This one is n square minus I square x square. So we can do that since I square is minus 1, and then we can do the same formula. So we will have pi times cot pi ix by minus 2ix, so minus 2xi plus 1 by 2 times ix square. So just put ix in place of x, and now we know that cot of I theta equals to minus I cot as theta. This one is also easy to prove. Just use the formulas for hyperbolic functions, and this will be then minus pi cot as pi x by 2x. Okay, so minus comes in front and cancels, and minus 1 by 2x square. So this is the formula, and if you want to find, let's say, sum from n equals to 1 to infinity 1 by n square plus 1 square, that will be pi cot as pi by 2 minus 1 by 2. So this was easy. and hope you enjoyed these derivations and the wonderful formulas for the sum. If yes, do like and subscribe the video and channel. Thanks for watching. Look forward to seeing you in the next video.